All right. So determine the minimum volumes of 0.50 molar Na2SO4 that is required to completely react with all the barium ions in 250 mils of 0.150 molar solution of BaCl2. So this seems a bit complex at first. And if ever you don't understand a question, the first thing you need to do just to have something written down is what? What should I do to have something written down? Let's do an equation. There you go. So let's do that. We'll make our double displacement style of equation here. So we have our Na2SO4, and that's aqueous. It's reacting with a solution of barium chloride, BaCl2, aqueous. And that's going to produce, so it's a double displacement. We'll get barium sulfate. Yesterday we saw in the solubility table that barium sulfate was solid. So I remember that from there. And then we have sodium chloride, which is soluble, so AQ. And that's, again, from our solubility table. We'd have to make sure it's balanced. So I could put a 2 here, a 1 here, a 1 here, and a 1 here, and we're balanced. And I'm going to go write information down. I'm going to put that I have a concentration of barium chloride of 0.150 moles per liter. And I have a volume of 250.0 milliliters, which is 0.25 liters. So now they're asking me, they also told me the concentration of the Na2SO4. So I have 0.50 moles per liter. Now, what exactly are they asking me for here in this question? What variable do you think they're asking me for? Right. So don't be too confused by the minimum volume part. That just means what volume of this do I need to react exactly with barium chloride? Like so that there's no excess, there's no limiting, that they react perfectly with each other. What volume do I need? That's what they're asking there. So we're asking for the volume that's required to react perfectly with the barium chloride. That's all they're asking for in this situation. Now we know our lovely formula here, C is equal to N over V. So we could find the volume by doing V is equal to N over C. What's the only thing we're really missing to complete this formula? Because we have concentration. What do we need to complete that formula? Right, we need the moles. But how do I find the moles? Right, mole ratio, it's something you know. Exactly. So we have a concentration and volume here. We could also write this down. We could say the moles of the barium chloride, so this will be our step 2 here, moles of barium chloride is going to be equal to C times V, which is 0.150 moles per liter multiplied by 0.25 liters. So 0.150 multiplied by 0.25, and I get about 0.0375 moles. So what's my next step? What's my ratio between the barium chloride and the sodium sulfate? Yeah, 1-to-1. That makes this easy, right? So since we have a 1-to-1 ratio between barium chloride and sodium sulfate, the moles of your barium chloride are equal to the moles of your sodium sulfate. In other words, 0.0375 moles. So we found the moles of our sodium sulfate. What's our last step? Find the volume. So now that we have the moles here, we can go and find the volume with that little equation there. So volume is equal to N over C, which is 0.0375 moles over the concentration, which is 0.50 moles per liter. Cross out moles and you're left with volume. So divided by 0.5, I get 0.075 liters. It looks like 2 sig figs is my smallest amount, so that's what I should end up with, which is good. I'm just also going to write or 75 mils. They didn't ask me for what unit, but just understand that when you first solve it, it'll be in liters because you have your moles per liter. And then if you want, you can just multiply by 1,000 to get your milliliters. Okay, so just to summarize here, in this question, we were told that there's a reaction between sodium sulfate and barium chloride. We wrote out the whole equation to make sure it was balanced properly with the proper mole ratios. The question was asking us, what was the volume of sodium sulfate required to react completely with barium chloride, given the following characteristics of the barium chloride solution? So its concentration, its volume. So what we did is we had the concentration of the sodium sulfate. We just needed the moles to find the volume from that. So we found the moles of barium chloride over here by rearranging our equation there to get this. And then we did our mole ratio between barium chloride and sodium sulfate. And since they were 1-to-1, the moles of barium chloride would react with the same number of moles of sodium sulfate, so 0.0375. And then we took that mole value and plugged it into this formula we set over here. So we did 0.0375 divided by the concentration of what we're looking for, which is Na2SO4, and that gave us 0.075 liters. That's 2 sig figs already, so we're good. But I also showed you the answer in milliliters to 2 sig figs as well. And so minimum volume essentially just means what's the volume that's needed to react completely so that there's no excess or anything like that, just that'll react completely with it. Okay. So that's the only tricky part, remembering what minimum volume means, which basically means just find the volume that would react with it completely. So are there any questions about that one? So it's a stoichiometry style question. It's a chemical reaction. When you're lost, write out that equation, put everything underneath it, and just find out what they're asking for. Even if you're not 100% sure what it means right away, at least if you know what they're asking for, you can come up with your formula and then use your formula to find whatever you think they're asking for in that case. In the next example, we're going to do another stoichiometry one, but with limiting reactants. All right, so let me just